Hey guys! Have you ever found yourselves looking for randomness but with some control? Generating pitch information, triggers, envelopes, slew limiting, and all of this in one module? Well, Flux is what you've been looking for. Let's start! Okay, so first of all, let's go through all the different sections of Flux and then build some patches together. What you can already notice is that we have 4 identical channels, so we will look at the first row and it will imply for all 4. On the left we have the mode selection switch. We can switch between 3 different modes: sample and hold, comparator, and off, which will bypass both sample and hold and comparator and will go directly to the next section, the attenuation. We have the range and offset knobs, and with using them we can control the lower and upper borders of our signal and have it exactly as we want it. Then we have the envelope follower / slew limiter switch. We can choose between linear or exponential slew limiting for creating smooth transitions between the voltages, and we can also activate the envelope follower, which will follow the amplitude of the signal and output a signal in its shape. Now we also have the rate knob, which will control the reaction rate of the follower / slew limiter. To the left, the reaction will be fast, and with turning the knob to the right, we can increase the reaction time. Then we have the signal input for the signals we want to process, the clock input, and the signal output. Like I said, all 4 channels are identical, so they will work the same, and of course, feedback modulation can really yield interesting results, so don't be afraid to send one channel to the other. Below the channels we have the modulation matrix like in most of the Vult modules, and also here we can assign a modulation source for almost all of its functions. We also have a master clock input for sending one clock to all different channels at once, and actually this is really interesting. When sending a clock to the master clock input and a gate to the individual clock inputs, each time the gate is high, it will sort of pause the main clock and the sampling. So now let's look shortly at the sample and hold function. The sample and hold function will work like any other sample and hold, but here we can choose the range of the signal and also smooth the transitions. So let's connect the clock to the clock input and a sine wave from our LFO to the signal input. Now each time Flux is receiving a clock, it will sample the sine wave and output this value, so let's see this on the scope. You can see the sine wave and the sampled signal. With changing the rate of the clock we can increase or decrease the sample rate. And now we can also change the range of the sampled signal by changing the range and offset settings. With the range knob we can change how far the voltage will go. In the center it will be full range. To the left we will decrease the range. But to the right we will amplify the signal up to 2 times as strong. And with the offset knob we can push the voltage up or down. Now we can also smooth the signal with increasing the reaction rate of the follower and create smooth linear modulation or exponential. Let me show you real quick about the clocks, so let's disconnect the clock and add another LFO. Now we will send the clock to the master clock input and a pulse wave, which will be our gate, from the second LFO to the channel's clock input. And you can see on the scope that every time the gate is high, and it has to be higher than positive 2 volts actually, so every time it's high the master clock is overridden and there is no sampling. Okay, so let's move on to building a patch using the sample and hold function. Okay, so first of all, let's add a source for Flux to sample from, and a module that goes really well with Flux is Caudal, also from Vult, and Caudal will generate random voltages for us to sample from, so let's see its first output on the scope. And let's send it also to the signal input of the first row. Now we need a clock to tell Flux when to sample this signal, so let's use a multiplied clock for this. And let's see on the scope what we get. So we have the voltage coming out from caudal and the sampled voltage. Now caudal will output voltages in the range of negative positive 5 volts, and I want to use this voltage as pitch information, so I will want to reduce its range a bit. And let's add quantum. Let's get rid of the scope and add quantum. Let's set up a scale and change the quantize mode. Let's add also 2 FM operators, there will be our voices. And let's add also stack, also from Bog Audio. And with it we can offset the signal coming in by semitones and octaves, so I will use this to raise the pitch of the second oscillator by 7 semitones. And now let's connect the CV output of quantum to both oscillators. Again, once through stack. And let's use also the gate output to trigger the oscillators. And activate their level envelope. Lower the attack time so we get something nice and snappy. And the sustain level. Send the signal from Flux to quantum and let's listen. Let's activate also the cables and listen to what we have got here. Very nice. Again, with the range we can change the range of the voltage. With the offset we can push this voltage up or down. And now let's use another channel of Flux to modulate the feedback amount of both oscillators. So we will need another signal to sample, and we will use the signal from the first channel. So we can connect the first channel's output to the input of the second channel. Now we will also use a different clock. So here I have a clock multiplied by 1.5 and also with a bit of swing set up. So let's use this. So the feedback will be modulated in a different rate than the pitch, but still they will have some sort of connection between them. And let's push also the offset all the way up, so we will get a unipolar signal, because we don't need the negative values of this signal. They will not affect the feedback amount in this case. So let's send the signal to both feedback amounts CV inputs. And now the feedback knob on the oscillators will act as an attenuator. So let's open it just a bit. Very nice, so you can hear the change in notes we get from caudal through the sample and hold of Flux. And also the feedback amount is changing and we get a lot of movement in the sound. And let's add another voice and let's use the new oscillator Blick, also Vult of course, and let's add another quantum. Maybe we can add even another note, let's add F. And let's use the Y output of caudal this time as our source. And let's use a much slower clock, so we get less change in pitch. And send the signal to the second quantum, and from there to the oscillator. Let's add also tangents. And let's lower the range of this channel, so we don't get too many high notes. And let's raise the offset just a bit. And let's see how this sounds like. So let's connect the output to the low pass input of tangents, and from there to the mixer. Very nice. What we can also do, we can change the follower rate, so we will get smoother transitions rather than jumps in pitch. And let's use the last channel of Flux to modulate the filter cutoff. So let's use another output from caudal. Let's use this one. And use our main clock. And let's send this signal to the cutoff point CV input of the filter. Let's take the range all the way up. And also the offset a bit. And also here let's change the follower rate so we get smoother signals. Let's open the attenuator. Yeah. Okay, so let's move on to the comparator mode, and also here it will operate the same way in all 4 channels. What the comparator will do in this case is whenever the input signal crosses the 0 point to the positive range, the clock will come out of the signal output. So you can see it here on the scope, the sine wave is crossing the 0 point and the clock is going through. With the range and offset knobs, we can set the borders of the incoming signal, affecting how the comparator will react. And in this mode, when connecting 2 different clocks to the master clock and the individual clock inputs, the master clock will override the individual clock and go through to the output. So let's see what we can do with the comparator mode. Let's use again caudal as our source. And send 2 of its outputs to the first 2 channels of Flux. And let's connect 2 different clocks to the clock inputs. Change those channels to comparator mode. And use these signals to drive a sequencer, so we will use ions. And send them to its both local inputs. Change also the clock mode of ions, of course. And run it. Let's also change the levels of the different steps and raise the probability all the way up, so we will get 2 16-step sequences. So now every time the signals coming out of caudal cross the 0 point of the positive value, the different clocks will go through and drive the sequencer. So let's add 2 voices, and we will use basal and slap. Slap will be our VCA and envelope generator, and let's add also 2 quantizers, this time from JW. Now we can send the sequences to the oscillators through the quantizers. And we will use also the same clocks that drive the sequencer to trigger the slap modules. Now let's send the oscillators through slap to the mixer and see how this sounds like. Now we can also use the other 2 channels of Flux to modulate both oscillators. So let's send 2 more signals from caudal to their signal inputs. Let's use this row, for example. And use again both clocks coming out of the first 2 channels to clock them. This will be the first channel and this will be the second one. And use these signals to modulate both oscillators. Open the attenuator. Let's push the offset all the way up so we get a unipolar signal. Let's also change the rate of the follower to get smoother signals. And let's actually also raise the octave of the second oscillator. Very nice. So this time we get triggers out of Flux driving ions. Ions is sending pitch information to both oscillators. Flux is also driving the SLAP modules and also modulating both oscillators. All of this in one module. Okay, so let's have a look at the last mode in which the incoming signal will bypass the sample and hold and the comparator and will go directly to the envelope follower. I have a sample here running through Flux to the envelope follower, and you can see the sample on the scope. It's the blue trace, and the pink trace is the signal generated by Flux following the incoming signal. And this is what the envelope follower will do. It will follow the amplitude of the incoming signal and generate a signal in its shape, which we can use for modulating / controlling all sorts of things like gain, cutoff point, delay amount, and so on. In this mode, there is no need for a clock, because the follower will be always active, and of course also here we can change the range settings of the incoming signal, and by changing the rate we control the reaction time of the follower, adjusting it exactly how we want it to be. So let's look what we can do with this function. So first of all, let's create something for Flux to work with, and for this we will use the note sequencer from JW, and we will use also 4 basal oscillators. Let's trigger random notes on the sequencer and send the 4 mono outputs to the oscillators. We can turn down the octave range of the sequencer a bit, and let's drive the sequencer using the simple clock also from JW. Now we can connect the oscillators to the mixer and listen to how they sound like. So this is the first one, second one, third one, and the fourth. Now for a bit more movement in the sound, let's modulate the oscillators using the polyphonic outputs of the sequencer. So I will take the first 8 outputs and connect them to the modulation inputs. And this will output normally pitch information, but we will use this to modulate them. And let's open the attenuators a bit. It already sounds better. Okay, very nice. Now let's use the envelope follower of Flux to generate a signal following the amplitude of those 4 voices. So we will send the oscillators also to the signal inputs of all 4 channels of Flux. And let's change all 4 channels to off mode. So they will bypass the sample and hold and comparator and go directly to the follower. So let's change the follower also to envelope mode, so it will be an envelope follower. Now let's add shortly also a scope and see how it looks like. I will take for example the first oscillator. So this is the first one, and let's take the first signal. And you can see this is the result that we will get. Let's take this down a bit. Now let's take the range a bit up, so we have a nice full signal. Let's do this actually for all 4 channels. And let's take also the rate a bit up. The reaction rate. So we get something smoother, let's say. Okay, and do this also for all 4 channels. Now we will use these signals to modulate a few FM operators, so let's get rid of the scope and add some FM operators. Let's add 4, because we have 4 different signals. And send the signals first through a Vult. To the level input of the oscillators. So it will control, or the signals will control their amplitude, their level. But also I want to control their feedback amount, so let's send the same signal to their feedback amount. And like we've seen before, when connecting something to the feedback CV input, the feedback knob will act as an attenuator, so let's turn it also up a bit. And let's take a listen. I will mute all the basal oscillators and let's listen just to the first FM operator, see how it goes. So you can hear there's a modulation in volume and in feedback, and this will correspond to the first oscillator. Now let's listen to the second one. This is a bit low. Let's change the settings a bit. This is better, so let's change all of them. And let's listen to everything together. Okay, now at this time they don't have a change in pitch, so let's use the signals coming out of Flux to modulate also their pitch, and we will use Erwin from AppleSense modules. Erwin is a 4-channel quantizer, and I will use also another Flux because I want to control the range or to attenuate the range coming from the first Flux here. So let's change all the channels again to off mode to bypass the sample and hold. And the comparator, I just want to use this section here, the attenuation. And let's send the signals from the Vult to the inputs of the 4 channels of the second Flux here. And now we can reduce the range, so let's take down the range quite a bit. Let's also take the offset a bit down, just a bit. Very nice. Now we can also change the reaction rate and get smoother signals. So let's do this also. And send all 4 channels to the quantizer, to the 4 channels of the quantizer. Let's set up a scale. And let's take the signal from there to the oscillators. Let's start with the first one, see how it sounds like. Very nice. Let's see how the second one sounds like. And they will work somehow together with the basal oscillators because they run or they are being modulated after the envelope, the amplitude envelope of the basal oscillators. Very nice. Now we can take this even further and modulate the range and offset of flux with using another flux. So let's duplicate this here. Let's move this a bit to the right so we have more space. Let's initialize it. Now we will use the sample and hold mode, and we will use also the, let's move it even more because I need more space. I want to use the 8FO also from Bog Audio. Let's see if that's enough space. Yeah, so I want to use the 8FO, and the 8FO will output different phases of the same LFO, 8 different phases. So let's make it a unipolar LFO by pushing the offset all the way up and send 4 different phases to Flux. So let's take the first one and let's jump to, let's skip one now and let's skip another one. Let's make this also a slow LFO. Now let's say as clock, we need some sort of clock for the sample and hold here. Let's use the gate outputs of the sequencer. So let's use the first 4 from here. They will be our clock for the sample and hold. And now we can use those signals to modulate the range and offset of this flux here. So let's connect all of them to the modulation matrix. And now by clicking the letter here and moving the knob I want to modulate, let's choose for example the range here. You can see it's a change here to range, and now I can turn the attenuator. Yes, and it will modulate the range of the first channel. Now let's take the second one and modulate the offset of the second channel. Open the attenuator. And let's take the third one to modulate again the range. Yeah, that's cool. And let's take the fourth one and modulate again the offset. Let's take the feedback just a bit down so it's not so screechy. Very nice, and we have a nice sequence. We can also of course change the parameters of the note sequencer. We can take a division of the clock and trigger the random notes. We can also change the length to a much shorter sequence. Let's take the levels of the solo, let's call it solo, solo voice, a bit down. Yeah, very nice. So again, just to recap, we used the first flux to create a sort of envelope or a signal from the amplitude envelopes of the basal oscillators. We use this signal to modulate the level and feedback amount of the FM operators, but we also used it to change their pitch through Erwin. And we modulated or we controlled the range and offset of this flux module here with another flux module on sample and hold mode. And I think that's it, guys. That was it. That was Flux from Vult. Like always, there will be a link to all the patches we looked at today in the description. I hope you enjoyed this video. If you did, please hit the like button. If you want to see more videos like this, please subscribe and hit the bell. And have a good one.